everybody, this is Poojitha from Narayana Vijayawada branch of 8th standard. Today I am here to explain you a topic of atomic structure on quantum numbers. Now going to our quantum numbers. First we have quantum numbers, 4 types of quantum numbers. The 4 types are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Now going to our first quantum number, which is principal quantum number. Now principal quantum number, it is denoted by small n and it has a values n equals to 1, 2, 3 and so on, and it is proposed by Niels Bohr, and as it increases, the electron has more energy, is farther from the nucleus, and we also have an energy relation E1 less than E2 less than E3 less than E4, but the energy difference between them, E2 minus E1 will be greater than E3 minus E2 will be greater than E4 minus E3, and we have also formula R equals to 0.529 into n square by Z angstroms, and energy equals to minus 13.6 into Z square by n square electron volt per atom, and we can also calculate the maximum number of electrons in an orbital. That means if n equals to 1, the number of orbitals will be n square, that is 1, and if n equals to 2, the number of orbitals will be n square 2 square, that is 4, and if n equals to 2 and if n equals to 3, the number of orbitals will be 3 square, that is 9, and if n equals to 4, the number of orbitals will be 4 square, that is 16. Now going to our second quantum number, which is azimuthal quantum number, represented by small l, and it can take values from 0 to n minus 1, and it mainly describes about the spatial orientation of an electron in space, and it also says about the possible shapes and energy, and 0 to n minus 1. For S it is 0, for P that is 1, for D that is 2, and for F that is 3. Now a second quantum number, and it also says about the number of orbitals in a subshell, that is equals to 2 into 2l plus 1. And now for S, as I said before, for S it is 0, for P it is 1, for D it's 2, and for F it's 3. Now going to a third quantum number, which is magnetic quantum number, and denoted by small m, proposed by Landay. Now it has values from L to minus L, including with 0, and it is also dependent on azimuthal quantum number. Now it holds and it also says that each orbital can hold a maximum electrons of 2, and it has minus L to plus L. Now it also says about the orientation of an electron, and we also have a formula to calculate m, that is equals to root over L into L plus 1 into cos theta, where theta is the angle between angular momentum vector and z axis. Now going to a fourth quantum number, which is spin quantum number, represented by S. It mainly says about the spin of an electron in an atom. If an atom, and it is proposed by Uhlenbeck and Goudsmit, and it mainly says about the spin. If an electron has a clockwise spin, the value of S will be plus 1 by 2, and if has an anti-clockwise spin, the value of electron will be minus 1 by 2, and we have also the formula to calculate the spin angular momentum, that is equals to root over S into S plus 1 into H by 2 pi, and we can also calculate the spin multiplicity, that equals to 2 into sigma S plus 1. Now at last we would see an example which gives us a clear information about what we have listened. Now going to our example, they have asked what are the 4 quantum numbers for the electron of the highest energy in the nitrogen. Now going to our answer, if we see the electronic configuration of nitrogen, we have 1s2, 2s2, 2p3, and where n equals to 2, as it is a 2 subshell, n equals to 2, and where and the last electron is in 2pz. So here we should consider for 2pz only value 0. Now n equals to 2 and L equals to 0, and m equals to 0 as L equals to 0, and S equals to plus 1 by 2 as it is a clockwise spin. Hope you all understood my presentation. Thank you.